Hi there and welcome back to Triplicate and moving on with the mean green. Part 9 I think. Trying to crack on and get the thing working. So since the end of the last video I've done quite a lot of coding, so without further ado let's see where we're at. Okay, so I have all the rest of the controls now working except the menu buttons, which you're going to use to access menus like load save, which are not implemented yet, and I haven't done anything with the joystick yet, and we will look at that in detail in a future video. So yeah, we'll just have a quick look through these. So I put the porter in, and to do that I had to put the keyboard module in the code. Up to now the MIDI was just going straight into the voice, and in doing that I've done something to it and it doesn't make a noise anymore. However, we will rectify that anon. So the output level, that works, the panning works, the panning modulation works, the effect, don't know what effect I'm going to put on it, if any. I'll put something on it, a bit of chorus or something, we shall see. And the envelopes work, there we go, and we can switch between envelope 1 and envelope 2, and it even says in the menu envelope 1 or envelope 2, and you can see the values change as it flips between the envelopes. And finally down in this here corner we have the LFO, and this little button will scroll around the waveforms available, and again you can go between LFO 1 and LFO 2. So now I am going to start to get it all working. So I'm going to go through and make a list of all the parameters implemented and not yet implemented, decide which ones I need to work now and which ones we're going to get working later, and then put them in some sort of order and work through them and get them all working. And most of that will be off camera. I will just bring you back when there's something interesting to debug or we need to change something because my original idea doesn't turn out to work as well as I'd hoped. So onward and upward. So okay, I've made a table of all the parameters for all of the mean green as they are at the moment, and you see I've greyed out the ones that we're not going to look at in the first hit. So firstly I am going to look at the oscillators, but as it is, since I've added the keyboard functionality, there's nothing coming out of it at all, so I'm going to somehow for now fix the keyboard into its basic mode so I can get notes to the oscillators, and I shall probably bypass the filter initially. Okay, so after a bit of fight I got all the bits of code in for the keyboard handler and all the bits of code out that weren't required anymore from implementing the keyboard handler, and finally we have a synthesizer that plays the notes you're playing on the keyboard. And I have disabled the filter just so we can hear the oscillators clearly. So we have two oscillators, but they're both set up exactly the same, so I shall take oscillator 2 and change the pitch. As you can see, it's quite hard to set the pitch up, and that is and it's so that's set them an octave apart. But as you could see, I was struggling to set the pitch to what I wanted it to, and currently the detune effect is doing the same as the mix pot, which is a bit of a bug. So what I'm proposing to do is make the pitch semitones, as is normal on oscillators, between 2 octaves up and 2 octaves down in semitones. The basic pitch, the detune is 1 semitone up and down 1 semitone, so you can tune the oscillators apart very slightly, and the pitch modulation is all off the pitch button, mod source and mod amount, and is such a way so small amounts of pitch modulation effectively modulate the detune, and large amounts of pitch modulation modulate it however many semitones. I'm going to try that, and I will try and figure out how I'm going to do that, and I will update you. Okay, so we're working on the oscillator pitch and detune. So I've set it up. So we've got 2 oscillators. Again, the filter is disabled, so that's raw oscillators we're getting into. And if I get the mix out here, so that's oscillator 1 and that's oscillator 2. And if we go into oscillator 2 and grab the pitch, so the pitch is an octave, 12, and turn that a bit up a bit for you. You can hear it. So that's a fifth, 7 semitones. An octave. And if you listen carefully, you can hear the 2 oscillators gradually changing phase relative to each other. That's because an octave isn't exactly an octave. Disadvantage of using floating point in that it's never exactly accurate, and that's floating point calculation errors. Just enough so the 2 pitches are not quite an octave apart. And here's the detune. Okay, so the detune is plus or minus 1 semitone, might make it plus or minus half a semitone. So now we have pitch modulation. So if we go back to oscillator 1 and back up to the pitch modulation, there we go, the pitch modulation currently set to 0 and the modulation source set to LFO1, right. Now if we, so we're in oscillator 1, increase, So at the top that's about the same pitch as oscillator 2, so it's going up and down an octave flat out. Come on. Is it gone into D tune? And that's 1 on the pitch modulation, which is too much for the minimum. We want to actually modulate it down in detune sort of ranges. So we need to do something about the pitch modulation to make it more at the top end and less at the bottom end. Okay, and here's the equation I'm going to use. Y is the modulation amount in semitones, and X is the pot value, which is sine, so it's 0 to 64. In MIDI numbers, so alpha we're using to set the amount of exponential we get. So we need to calculate beta so that when X is 64, Y is 24, because we're going to get it to go between plus and minus 2 octaves at max. I don't know whether this is too much, we'll try it. It's just a calculation so we can change it. So then we can calculate beta from alpha by this equation and that equation. And I have generated a little spreadsheet to show these curves in action, so to speak. Okay, so I've just generated with a little spreadsheet some of the possible curves, and here is the alpha values I'm using in this equation, and here are the beta values calculated from the equation. And then for the input, which is 0 to 64 down here, dx, we get 4 curves for the 4 alpha values, and you see that one is not far off a straight line down to this one, which is quite a strong curve, so we get very little change at the bottom and a lot at the top. So there we go. So I'm now going to code that into a table, and we are going to try it out for our pitch modulation. Okay, so I have implemented my pitch modulation table, and so we have the 2 oscillators an octave apart. Oscillator 1, oscillator 2. And oscillator 1 is the one we are modulating the pitch of. With LFO 1, and I'll use the value pot. That's -1. Just hear the modulation there. Right, I'm going to go back into the Excellent. And that seems to me to be sort of a natural detune modulation at the start to wacky pitch modulation at the end. There we go. So that's ramped. I've now got the ramp wave on the LFO, so I'm checking the sine works on the oscillator mod. So if I go and I'm back in there. I need a menu lock of some sort. So we're going up there, we're ramping up. Yep, and the sine works. Okay, so I'm happy we have the pitch, the detune and the pitch modulation working to our satisfaction. So, onward and upward. Okay, so there you go. I think all the oscillator controls and modulations and modulation sources are good, and there we go. Modulating the waveform width with different LFOs. Interesting. Okay, so now I will turn the filter back on and we will have a look at that. So we have the filter frequency, the envelope modulation, we have another modulation, typically an LFO, the resonance that can be modulated, and I have added okay, key follow. So okay, we have a basic sound here, and if we turn the resonance all the way up so we can hear where it is. Okay, you can hear the key I'm playing does not affect the cutoff frequency. However, if I go into where are we? The key follow and set some of that. Try again. You can hear the resonance is following the keys, sort of. I'm not entirely sure what setting of that corresponds to the resonance exactly following the key note, but there we go. I shall find that out at some point. So if we move on to the porter, now the only way into the key control menu is by moving the porter pot, so we do that. We've got keyboard config, done that. Multi. And if we add some, let's add some portamento. And I did go through and like the portamento speeds I tweaked so it worked a bit nicer, and similarly the cutoff frequency. The range was far too wide, and the resonance I changed just so they work nicer, just so they work better. So if we now try auto glide. That works. and I have implemented key velocity, which is set to 127. So we can also use that as a modulation source. So let us modulation source, velocity. You can also use the pitch as a modulation source, not just for the filter cutoff, but we're going to stick velocity on our cutoff frequency, and we are going to have a bit of modulation, something like that. And I realise you can't see me playing the note, but you can hear the cutoff frequency going up as I play the note harder. Okay, so starting from our fairly basic little sound, let us now look at the output section. What do you want to do first? Panning. So I realise this isn't going to work with where the camera is, and the camera records in mono, but anyway, you'll hear it doing something. So the basic panning, something clicked back then. So we can also modulate it, pan mod, modulation source. Should we try trusty LFO1, modulation amount. Right, we'll go negative for the sheer joy of it. Well, you'll have to take my word from it, that is panning, but the camera's nearer one of the speakers than the other, which is why it seems to be coming in and out. Right. So if we take the panning off, well, actually hard, really hard to actually set to 0. So that's something we need to address. Gotcha. So there's no panning now. Right, so cured a little bug on the level modulation. So now we have level, and we have level modulation, which is like a, what do you call it, tremolo effect, I guess. So mod source, LFO1, mod amount, something like that. So we now have okay, set it as maximum. There we go. It goes up and down with a level. And the level I actually put in linear, not logarithmic, because I find if you're looking at a level that's sort of relative to the rest of your mix, linear actually works best in that case, whereas if you just want the volume control, that's when you want a logarithmic curve. It's something you just sort of do by ear, and I might change the curve because it does die a bit at the bottom. Oops. I might put it logarithmic, who knows, for the future. So I think that is it. Everything for our first hit, and I know the joystick isn't going yet, but for our first hit I think I have got everything working and reasonably tested. Okay, I think I'm going to call it a day here for this video. Got pretty much as far as I wanted to get. Next time we are going to get a memory chip, connect that, well, the memory chip on a little circuit board, connect that up to the STM32, get that working and make it so we can save our programs that we can now edit to our heart's content. So until then, it's goodbye from Triplicate, home of interesting electronics. Goodbye.